Hello everyone, welcome to new video. In the last video module, we have discussed about energy generation. In this video module, we are going to discuss about the generation of electrical energy. Most of the electric power plant are based on the principle of electromagnetic induction, which are invented by Michael Faraday. So that's the reason the SI unit of induction is Faraday. According to this principle, whenever magnetic field around a conductor changes, a potential difference is generated across the conductor. The field around the conductor can be changed into two ways. If the conductor is stationary and magnet is rotating, or magnet is stationary and conductor is rotating. The field around the conductor changes or if a magnet is stationary, but the conductor is moving, then also the field around the conductor will changes. Thus, in both these cases, a potential difference is created across the conductor. The electric power generation machine based on this principle, that's why it is called as electric generator. Student, I just wanted to give you a definition of electric generator. What is meant by generator? The device which used to convert mechanical energy into electrical work or mechanical energy into electrical energy is known as generator. Generator. In the name only we have generate. Generate means what? Create. Okay, creation. So that is why it is called as generator. See students, as we can see, whenever magnet is rotating in current electricity, last chapter that generator and motor we have discussed it in detail. So that is why here, if you don't see that video, so please go and check in the playlist. So you will find it out, the working and construction of generator and motor. Okay students, now we know very well electricity is generated by various method, by using solar panels, by using wind turbine, by using hydroelectric power plant, various devices we are used. Okay students, so electrical energy generation is nothing but the conversion of one form of energy into the different form of energies. As we previously discussed students, energy can neither be created nor be destroyed. It just convert from one form of energy to another form. So that is why it is whenever we provide whenever we give the form of energy to the generator, we start rotating. A windmill, steam turbines, electromagnetic induction are the examples of that. Okay students, electromagnetic radiation. Now on the screen you are able to see the large generator are used in a commercial power generation plant. Turbine is used to rotate the magnet in the generator. A turbine has a blade. When the flow of liquid or gas is directed on the blade, the turbine is rotated. Because of this kinetic energy, the turbine is connected to the electric generator. Thus, magnet in the electric generator across start rotating and electrical energy is produced. See students, right now on the screen, steam turbine you are able to see, from where high velocity steam will be entered from the nozzle to the blades, and whenever it hits the blade, the turbine start rotating. Wheel and the shaft which is connected to the generator also rotate the generator shaft. Because of that, what happened beta? Magnet becomes stationary and the conductor start rotating. Sometimes the shaft is connected to magnet, so magnet start rotating and which means that the conductor becomes a stationary. Dependent on construction we have used in it. So here what exactly happens, whenever steam reaches on the blade, so blade start rotating. Whenever blade start rotating, the rotating electric magnet also be placed to the nozzle, which is rotate that blade shaft into a mechanical work to electrical work. On the screen right now, you are seeing the schematic of electric generator. As you can see, rotating electric magnet, upside of that generated electrical energy, and the two poles are also there, north and south, as you can see in the screen. See students, what exactly happened? This method of electrical energy generation can be represented by a following tagline. Thus, first of all, what exactly happens? What exactly happens? Proper energy sources to run the turbine, which is here steam. The turbine start rotating and the nozzle and the wheel shaft also start rotating. These shaft is connected to the generator and the generator start rotating. These generator convert mechanical energy into electrical energy. These to be generate electricity based on the principle of electromagnetic induction. We need to generate generator. To rotate the generator we need a turbine, and to drive the turbine we need a energy source based on which the type of energy source is used rotated the turbine. There are different type of power generation stations such as a hydroelectric power plant. As you can see on the screen, hydroelectric power plant is nothing but the power plant which use the potential energy of water, which use to convert the potential energy of water into the electrical energy. Thermal energy based electric power station. You know students, the thermal energy based electric power station. In this, the turbine is rotated using the steam. Water is heated in the boiler using their energy release due to the burning of coal. Steam engine of very high temperature and pressure is generated. This energy in the steam drives the turbine. Thus, the generator connected to the turbine rotate and the electrical energy is produced. The steam engine convert back into water and the water is recirculated to the boiler. This is shown in the following chart on the screen right now. You can see in the following chart, fuel converted boil for the conversion of water into steam. Steam turbines start rotating and steam for converting the steam back to the water. Next, steam turbine is connected to the generator and the generator generates the electrical energy as we need it over here. This is the construction of thermal electric power plant. On the screen right now, you are able to see the thermal electric power plant. Thermal electric power plant is the power plant which convert chemical energy of a coal converted into thermal energy. These thermal energy converted into kinetic energy in the steam. Kinetic energy in the steam converted into kinetic energy of a turbine, and then turbine start rotating the generator and generator create the electrical energy from the mechanical energy. Okay students, as you can see over here on the screen, thermal power plant. If you see the thermal power station, you will observe two type of towers there. What are they? If you observe them, so schematically you are able to see the combustion gas to stock. Second is cooling tower on which a vapor and the hot air comes out. Compared to the schematic of the thermal power station with the block diagram which you see on the screen, and you will be understand how the boiler, turbine, generator and the condenser are arranged together in the power station, because the schematic arrangement of these delicate devices is used to convert the kinetic energy into electrical energy. After combustion of fuel, here coal, petrol, diesel, whatever the fuel is there, fossil fuel will be used in this. In the boiler, the emit gases are released to the atmosphere through very high tower. Once the turbine is rotated using the steam at a high temperature and the high pressure steam temperature, and the pressure decreases, this steam is converted back to the water by taking out heat from it. This is done in the condenser using the water in the cooling tower. The water in the cooling tower is circulated through the condenser. Heat energy in the steam is given to the water and the steam condenser back to the water. The heat absorbed by the water is then released to atmosphere through vapor and heated air through cooling tower. Although thermal power generator is a major way of electricity generation today, it suffers from a certain problems as well. You know students, what are the problems? So the first problem is air pollution. Air pollution due to the burning coals, because fossil fuel burning creates a sulfuric oxide, carbon dioxide and nitrogen oxide, harmful gases it will be created. Because of that, it will be harmful for our health and atmosphere as well. Second drawback is, along with the emission of gases due to the burning of the coal, soot particles are also released into the environment. These may cause us a serious health problem related to respiratory system, because students, whenever such a small infinitely particles shoots spread into the atmosphere, creates a emission, and when we get inhale or when we get contact in it, so we soak it and we have to suffer from a respiratory diseases. The reverse of the fuel used in the method, that is coal and the limited, therefore in the future there will be limitation on the available of the coal. Students, some of thermal power plants you are able to see on the screen right now. These thermal power plants are used to generate the electricity towards in India. Some major thermal power plant in India and their capacity is given. See, first is Vidyanagar. Vidyanagar, which is situated in Madhya Pradesh, having capacity of 4760 megawatt. Second is Mundra, which is situated in Gujarat, which has a capacity of 4620. Second is the same, which has a capacity 4000. Next is Tamannar, which is located in Chhattisgarh, having the capacity of 3400 megawatt. And last is Chandrapur, Maharashtra, that is 3340 megawatt electricity is generated. Students, just tell me, you get electricity. From which power station you get the electricity, that you have to tell me in the comment box which is given below. Students, I hope you understand this phenomenon. The power plant based on the nuclear energy point, we are going to discuss detail in the next video module. To get the notification of this video module, you have to subscribe the channel. And whenever you subscribe the channel, hit the bell icon to all. Whenever I'll upload the video, you'll get the notification. Thanks for the watching. Thank you.